Hello everyone, welcome to another stream. How's it going? Suppose we're live. Right, so yesterday we were working more on this DAG. So this, wait, why it's called a DAG now? The directed acyclic graphs. It's basically just a graph of one too many inputs and outputs. Sorry, one too many outputs and many to one input, something like that. No. Yeah, it's just a graph with many inputs and many outputs. That's the right way of saying it. So you just basically build a bunch of nodes, and each node is going to be like a each node is going to be a command which gets executed, and we've got other nodes for the files. So I guess those might be edges. I'm not sure, but so effectively we've got this build system, and it's been all right. The whole point is that we want to have a build system written in C, such that you can run it and it just sits there and watches for your files that change. And then when you change a file, it'll recompile it automatically without you having to run it. And then it will start, it'll tell the game to like reload new code or reload new assets and that sort of thing. So this is what we're building towards. It's been able to reload shaders and code, but not assets yet. We're just sort of reworking it such that it's a lot more of the design flaws have been removed, basically. So you used to just initialize these commands, and then it will basically execute those in order. So when a file changed, it will execute the commands in order again. The commands which have had files which have changed. So you'd place barriers down, and the barrier would simply say, "Hey, wait for everything before me to finish before we carry on." So that this approach actually it's not as efficient, right? Because if you only have one stream of commands which can be executed, it's not as good. So a more better approach, if you want to have all of your threads occupied with something to do, is to have a graph, right? That's the basic idea. Build a graph of all your commands to execute of inputs and outputs, and you can just execute it. And actually, as you execute, you can always continue to build the graph, right? So this is why we're building a graph, and we're getting very close to having it finished. We just got to iron out some of the problems. So we've just got one of them kind of working at the moment, which is all of the shaders. So we're able to say, we define a command which is, some shaders, and the inputs is simply these files here. And we'll be able to get all the dependencies automatically by via the compiler, basically, which is cool. Anyways, I'll just start off with a quick prayer and then we'll get going. But yeah, any questions, feel free to ask away. Father in heaven, thank you, Lord, for this day. We bless your holy name. Thank you for food on our table, breath in our lungs. Thank you, Lord, for being there for us when we're not there to represent ourselves. And thank you for your mercy, your grace, your kindness. Allowing us to be born in this age where things are quite easy. Food's accessible, information is accessible. It's a great time to be alive. It's quite an easy time to be alive, so we thank you, Lord. Just pray that you help us, Lord, with these tasks ahead. Help me, Lord, get to a place where the game and engine is ready to start building some game prototype, and help me make sure that this game prototype that I'm going to be presenting soon is good enough, is worthy enough, is what you want me to do, and will yield fruit for the kingdom of God. Thank you, Lord. I also pray that our viewers here, that you help them. If there's any issues they're going through, Lord, struggle in their life, help deliver them from that struggle, Lord, and reveal, Lord, that you are good, you are holy, and that you do love them. And, I pray that each and every one of my viewers will one day receive the gift of salvation from you, Lord Jesus, and accept that your blood is the only payment that can ever pay the sins of man. We want to still enter into heaven to be with you, Lord God. Thank you, Lord. In Jesus' name we pray. Amen. Cool. Right. So, I hope we're all having a good day. So we output a file last stream. It was called DAG dot, I think. This guy. So the beautiful thing is, the beautiful thing isn't I have to keep using Visual Studio Code, but here we go. We can output this text file and view a graph, and it's amazing, right? That's cool. Seems like this one's not compiling. it's weird. Or it's pointing to itself. See, there's still problems to fix. We've got quite a few little issues, right? So the thing is about C files, GLSL files, is they actually have... So how do we define... So we know how to define the output, right? We basically just change... We get the file path. We just change it to like spear, this one.spearv, right? And this one.d for the depths file. And then that's the outputs done. But the inputs to this, to compile this single input file, the things that we're dependent on, we need to fish those out from a GLSL-C depths file. So, but you only get this once you've compiled it the first time. But thankfully in Clang, there's a way to do a dry run with a -m. Now I'm wondering if there's a dry run in GLSL-C, basically. Hey there, Elise. Okay, this is not a real person, is it? Right. Okay. So this -m is called dry run. It does exist in GLSC. Thankfully it does, right? Amazing. So basically, if we don't have a depths file, if that does not exist on disk, we need to run this command with a -m. But it doesn't generate a SPIV binary, right? It just parses and let's set the include files. Yeah, okay. Cool. So that's what we need to do. So we do like OS file exists. Are these null terminated? Yeah, they are. Cool. So if the file does not exist, what we actually want to do is a dry run. Just curious, though. So we do a dry run. That's going to output a... Yes, I wonder what we can do. We could build a graph, and it's like, this one just outputs a... You output an extra node, which outputs the .d file. Yeah. So I think this needs to be an input and an output. This depends on it existing. But if it's a dry run, if the depth file doesn't exist, we do a dry run. So need a dry run pass as the depth file. The depth file, yeah. So obviously when we run the build system for the first time and never ran it before, it's going to have to do this. But in future runs, it's going to have a depth file, so it can just rely on that one, which is cool. Yep. So we need a dash m. So this would be a VK shader depth file. That's what it's to do, is to make one of those. So its input is the input file. It has no input of the depth file. It doesn't output the SPIR-V file, but it outputs the depth file. Nice. So this is interesting. So maybe we could delete. I wonder. Yeah, it's going to include the. Oh, we better. It's not null terminate anymore. Sorry, it's null terminate, but it's not. The size doesn't point to the. The size will point to the null terminator instead of afterwards the null terminator, right? So it doesn't include the null terminator as part of the size. Okay, that'll be cool. So if we delete, I think there's some more problems, but let's delete the build directory from it. And let's see what happens. Does it crash because we haven't made the... I think it crashes because we haven't done a make directory on the build. So we need to do that right away. All right, this will work. Okay, this is an assert here. Right, so file node already has creation command. Right, so basically the file is trying to be made multiple times. the dependency file. That's interesting. Yeah, that is the case then, isn't it? You can actually have or why don't we just execute the command right now? But you want to execute it in parallel, that's why. So if the depth file doesn't exist, you want to run the same command again, but with a -m in it. And that's going to go into the graph, right? That's going to go into the graph, but you only really want it to exist and run once. You kind of want to make it disappear after the next execution, but also you have the file as an input and output. Yeah, I think maybe that assert is not good. Right, so maybe the way we're doing this graph is a little bit wrong. Yeah, so if a file gets changed multiple times over a series of changes, so a series of passes will change a file. It really is input and output it. It is possible, right, for that to happen. Just made it happen. So, like, for instance, if you draw, just draw it, I guess. So you could have a command, then which outputs a file, which then another command will take in. And then another command is going to output the same, a modified version of that file, right? So the question is, say if you want to then make a new, like you already have this DAG built, right? So I guess it's command 1, command 2, and file 1, file 1. Yeah, so the same file. This, like, how do you say, I want to make a new command, which is going to be dependent on this version of the file, right? So command 3. Or how do you say actually it should be dependent on this version, right? So it must mean then that every single time. So I think what we need to do is keep rebuilding the DAG, right? Because I think what it starts to do is make yeah, I think we just keep like blowing the memory away for the DAG and then rebuilding it, because then it allows us to have some kind of order of declaration which links up nodes, right? Yeah, I think that's the way we'll do it. So that's how we solve this problem. So a file, you can't really have a file node anymore. Maybe you can. Yes, you can probably have a file node, but you can have the same file node declared twice. I think. It's just a different version of that file, right? Yeah, I think that'll work out. Creation command node. I think maybe you have to overwrite. So rather than dedupe, so it's either find or insert latest. Find or insert latest. But then that's only when you're trying to read, but when you're trying to output, you're trying to say make a latest one, aren't you? Yeah, I see. I see. Hey, Navi W, welcome. Yeah, holiday. Holiday was great. Then we saw the pictures. Pictures laying about, I think. Yeah, I went to here we go. Went to Santorini. So this is on top of the monastery. It's the highest point of the island. And you can see basically the whole island. Here's the tail. And here's the sunset. See the color banding in the compression artifacts, but it looks really great. That's the sun over there, just. And here was a beach we went to. It's got black sand. And here's just a picture of a local church. And here's just some more pictures of the island. It's got like red cliffs in some cases, and yeah, that's it. It was a good time. Yeah, family had a good time. Went on a boat. Went for a swim in the sea. Off this and swam to the shore from the boat. Swam back. What else did I do? We did a barbecue there, of which I nearly like destroyed my lungs trying to set the fire alight. Like fires burn really well when you don't want them to burn. Yeah, but they're very difficult to light when you want them to be lit. What else did I do? But yeah, it was a good time. Good time. Family had a good time as well. Good to be back as well. Yeah, it's really nice. So it's off of Greece. And we found out as we was leaving, there's no proper doctors there as well. So if anything bad happened, we would have it would have been great. But thank God there wasn't any incidents. So it's great. Yeah, how's things been with you, Naveed? Yeah, so I think we're gonna have a file node find latest, find or insert, and then we have one which is just an insert. Right. So that will insert a new one. So when you define a new output, you're just going to do insert, but if you're trying to find an existing one, it's find. No, it should just be find. Yeah, so for all the source assets, we should just do an insert. Yeah, no, it's just a find. And if not, it's going to assert. Nice. Yeah, so we're going to we're going to have to keep rebuilding this graph. That's fine. So the file node will have a creation command node. That's right. Yeah, so this doesn't have to change that much, really. It's cool. So I'm thinking like the ID should really be what are we doing? The ID of the file node, yeah, should be F then the index, right? So does graph dots, that's the AI again. Does graph viz dots have a sort of a hover label? Does it have one? Tooltip attribute, that's what we want. Yeah, so we want tooltip. Now I reckon, right, we can put in some kind of index here. So we'll call it C and then the index. So that'll be the ID for the node. So you'll put in uPointer index equal, oh no, I already got it, done. So we do the same thing, but instead it's going to be F for file node. And we'll have a label. We're going to say labeled though. Yeah, so it's just the path. Beautiful. So I'm thinking yeah, be fine. Lovely. So that means when we do the links for the nodes in this file format, graph is dots, we want to use indices only. Right, so you need to find the so the command index, what is the dep? Oh, that's linking it to itself. Oh, man, that's so silly. Yeah, so the command would be node command. What is that? String. Right, so that should just be index idx. So that means the file index would be dep node, take away d file nodes. Okay. Now here we go. It is simply, we're trying to say this file points to this command. So it's an input, right? Then we're trying to do it the other way around. Yeah. Nice. So those are the changes we need to make there. Now, we need to, there's a dedupe. Where is it? This one, file node dedupe, needs to be changed. There needs to be two different versions, just a find and a find, sorry, and just an insert, right? Hey there, Rix. How's it going? I follow if you follow too. Not sure what you mean. So you're saying if I understand what I'm doing, you understand too? It's a good place to be if so. It's fine. It's fine. I won't, I don't need followers, man. That was the point of a number. You know? I feel like, what's the point of words from people's mouths? It's what the heart matters, you know? Nah, why would I follow someone who's just going to follow me back? It's weird. This is why belief in Jesus Christ is from the heart, not from the mouth. Because if not, it's meaningless. 25 followers. If you want 25 followers, go do something. And pray to Jesus. Say, Jesus, help me get 25 followers. And maybe he'll help you out. Thank you, but yeah. Well, it's not already free. Nothing's truly free in life. There's always a cost to something. Right, so do a find. Is that your pointer to a pointer or a pointer? Get your pointer. So you simply just return. That could be null. And in which, then we probably just want to assert. Nah, I'm fine. If you want followers, go do something. Stream. Provide value. But me following you provides no value. Nah. Have a nice day, sir. God bless you. I hope you find the way, the truth, the life, which is Jesus Christ. In a bit. So, unable to find node this guy. Path, yeah. I'm not sure if half of these things are just AI, you know? Just people putting AI bots into chats and things to cause chaos. Why did I say chorus? I meant string format. Cool. Right, so insert is you do a find or insert, and you don't really care if it's nil or not. You just throw it in. Or some kid shouldn't be on Twitch, yeah. Yeah, I had some children in town who come up to me because I was preaching today. And yeah, you know what children are like. Just quite, you know, don't take stuff seriously, disrespectful, and, you know, so I persevered with them though, and eventually gave them the gospel, prayed for them and things, and they moved on. But yeah, they tell me all sorts of sins they've done, and yeah, I just find it, you know, funny and humorous or whatever, but, you know, it was all there once. So. insert a new node. Cool. That's the change we wanted to make. So when it comes to building commands, which we have this one here now, we no longer dedupe. So when we see that the file doesn't exist, so yeah, we might want a function to say yeah, so we should go over all the source assets, like all the ones in the build folder as well, and index all of that, make them into a bunch of file nodes, right? That's what we need to do. Man, there's so many AI spammers everywhere. I keep getting more of these silly messages. Do you guys see that one? No, thankfully not. AI. So we want to have a function which is probably called DAG. I know DAG in it or whatever, or DAG reset. So DAG reset is going to, yes, where's the indexed file or whatever it is? It's indexed, yeah, and so we should actually index the build directory as well. Yeah. Yeah, just know about everything. Should we? Is that a wise idea? Yes. Do we make them as file nodes? I think we do, right? Make them file nodes, and then we can yeah, I think that's fine. So on DAG reset, we can probably go over every single indexed file. Nah, I think that's kind of dumb. Right, so I think we need another piece of memory as well. In the DAG. The DAG alloc is probably a function we need. So every time we rebuild the DAG, every time we see a file change and see what needs building that way. So it's like immediate mode DAG, right? Make everything immediate mode. So on the DAG itself, I have a piece of memory, I guess, and a mem cursor. So it's got the lifetime of a DAG. Right. So reset is going to set DAG Mem cursor to 0. Let's do 8 megabytes worth, I don't know. Cool. So essentially the DAG here. DAG mem lovely. So there's a DAG reset function. We also need to clear out the arrays as well, so the nodes count 0. So we could put them in arrays. It allows us to iterate over them quite easily. Yeah, we'll keep them in arrays. Cool. Right, that's good. I like that. So now when it comes to allocating new nodes, we actually need to call DAG alloc instead of alloc. So it's the lifetime of a DAG. Yeah. Nice. So yeah, when we go, so let's come back to this guy again. So we're doing this sort of like shader. You know, we've got a bunch of input shaders basically based on some filter, you know. We go over, so we search the indexed file system, we get a bunch of inputs. We should be able to find the input file, but we might not. So yeah, I think you want to abstract it back as find or insert again. Let's grab that function. We need all of them. Just a wrap around the hash table. And a find or insert, okay? Right. So this input file, we probably, yeah, it could have been code generated or whatever. So you just say like find or insert, right? You don't care if it existed or not beforehand. The SPIV output node though, like you probably, yes, the dep node can come after. Something about it actually, these guys, the input file node, So if the depths file doesn't exist on the file system, problem. So we need to do a dry run pass, run the shader with dash, so run the exe with the -m. So it's a dry run pass. Produce the depth file node shouldn't exist. That should just be an insert. Okay. Yeah, that should just be an insert into the hash table. Make a new one. Then right, what else? So then we add, yeah, we make a new command node. It makes the depths file input node output. Then we run the real command, which will take in so we probably don't have a SPIR-V file in the node tree, so we just insert a new one. But for the dependency file, we should it'll be a find or insert. Then the input node, find or insert again. Lovely. Cool. Right, I think that's it. I'm wondering, like, this one can probably just be done up here. Because it's the same node. Cool. So this is probably closer to what we want. If we find what we're doing. So we'd always want to start with a DAG reset. Then we build a new DAG, right? Let's see how that goes. Right, so file node, bloom, downsample, already has creation command, whatever, right? So the is that dependency file again. So we actually would want a new dep file regardless, because it's an output file. Yeah. Right, so to make this a bit easier, is a way to rephrase this to more of use case rather than what's going on under the hood. It's like you want a new file node because it's an output. So you could say file node for input, file node for input, file node for output, and then for, you could do file node for input, which would be must exist or something like that. But maybe this is fine. All right, let's run it. Cool, so supposedly let's update a new tree, and it has, because we're seeing Fs, right, for the file nodes, and this is the new way we've decided to output it, right, is each file node has its own identifier, which is F, then its index, and now we've put the label in as a label, and there is support for tooltips as well. We hover over the commands, and they've got a tooltip for the actual command is under the hood. So this is the benefit of graph viz dots, that we can output these things and visualize the data to make sure it's all right. We probably do need a pass which will verify that it's a conceptually correct tree though, before going on to here. But yeah, so we've got this. Yeah, this is where you want the old one. Yeah. So see what's happening here. So we're doing this exposure compute shader. The depth file didn't exist, so it's running the depth file command. Now it outputs this dependencies file, but now this one's depending on itself, right? So what we actually want is the old dependency file to come in as an input and then output the new one as an output, right? So that makes a lot of sense. So you actually want a find or insert on the first one. So you would actually want this to exist regardless. So we can call this the before depth file and the after. So the input would be before. So it'd be a find or insert. So now we compile and run that. That should be the fix. Here we go. So here's a better graph, I think. So we're trying to compile this source file, right? But we haven't got dependencies files, so we do this first, yeah? And then it outputs this dependency file, which then... Now the issue is, we've got problems. The dependency file is actually needed for us, right? It's as if so maybe what we need to do is yes, maybe this is slightly wrong. We probably need to have a pre-pass which goes over all of these guys and figures out the dependencies. And if it doesn't have them yet, okay, there's a new way of doing it. So this is probably the wrong way. We might need a global to be like, are we finding dependencies? If we're finding dependencies, we might want to build a DAG which just searches for dependencies, right? So you could build some DAG, then give that to the command, to the DAG executor. That will execute the DAG and produce all of these dependencies file, maybe or something like that. Equally, I'm not sure. These things shouldn't be dependent on anything else to run, though, I don't think. To work out dependencies for stuff, I think you just need to run some commands. Could there be a case where to work out dependencies, you need to run something else first? Right. Hmm. Did you need... So the thing I think about is like maybe code generation, right? We have code gen. So we might run the code generation that will output a new C file. And then that C file needs to have the dependencies checked before it can run. Before it can run anything, right? Yeah, so maybe there's like this phase of discovery, right? I've discovered a new thing I want to build. What we should probably do is run it through a check find dependencies pass, and that needs to happen first before we can even add it to the DAG, maybe. And maybe we don't need a DAG reset. Maybe it can just stay. No. We'll need to reset it and rebuild it every time. But yeah, before we can. So we have an input file. Right, I got some ideas now. So we have an input file, we check. Those dependencies aren't ready yet. We can add that to some kind of like DAG find dependencies commands. So there's this thing called like command process. What's that thing? Yeah, so I used to have this thing called a command as well. And the barrier would wait on. Yeah, so I think we need a new kind of abstraction where essentially it's just running some commands and we just want to wait for all those to be done. So it'd just be a bunch of handles on Windows basically. And yeah. So we'll call this something like the DAG. So essentially it's just going to have a string. The command which needs to run. It has probably like a process ID or something like that. Then we can have an array of passes. So we'll generate the depths file, and then next time when we come around, we can read that depths file in and cache it in memory for the future. And we can use that to add a bunch of dependencies onto the note to the graph or something like that. So these things will just be running in the background where you just fire them off. And you just keep processing through them until they're all done. Then you can do the next DAG by resetting it and rebuilding it again and seeing what you need to do this time around. Potentially. So we want to say so it'd be some kind of command that you run, and Yeah, we want all of these to be done. Yeah, so I think if you go through and build a DAG and you just come across and find some dependencies to, you need to find dependencies before you can really execute it. Is there much point running the old DAG first? Maybe. Did you find dependencies, run the DAG, and then refresh and build the DAG again, and run the commands that you missed? I think that'll work. Yeah, the problem is you just got to limit the amount of processes you can run. Yeah, so I think we've got to have some kind of executor, which will basically keep track of the handles which are running, and when they're done, what to do about it. Right, so I think we'll do like a find dep. So it's the next one to execute. Something like that. So I think overall you want to have some kind of executor. And you just have a queue. And when you want to find more work, I guess you could either look at the DAG or the find dependencies thing, basically. So we'll have a list of handles that we're waiting on. There's a wait for multiple objects, isn't there, or something like that? On Windows, right? And it will wait for any, wait all or wait any. Yes, when any of them are finished, it wakes up, and then it tells you which one, right, with a return word. Yeah. So you'll basically have your array of handles. These are the ones which are executing. These are the handles that are running. There's a running count. Running handles. Running count. And the capacity would be the maximum number of threads that we want to distribute everything on, right? But then there'll probably be some kind of other thing here, like, you know, a queue of DAG nodes or something, right? So you have a DAG command node, and it's a queue DAG command cube. And yeah, you would just basically have a queue. Yeah, probably have a tail. Something like that, yeah. Then for the DAG here, there's these sort of find dependencies. I guess you have like a next to execute index, and once you've executed them all, you just clear the one from the DAG, right? So you'd have like a find dependencies next to execute. So that executor will exist. Cool. So you'd have executor you'll so we'll keep so you'll be spinning around in this executor. I think this is where you just do this might do all the watching as well and stuff like this. So I think we'll stick in here. Oh, here we go. So how we're going to do this. So essentially you have like a wait for multiple objects. You have a executor, call it E. Okay. So you just have your E running count, your E running handles. Oh, I forgot to handles that. It was in a plural. Then are we waiting on all of them? No. We're going to use the infinite wait, or always wait until they're done. Then it will wake up with some kind of result, and it will either give you an abandoned or object. So abandoned means that, does that mean it crashed or something? Yeah, so we want to know what the I've done it before, haven't I? Yeah, you want to get the exit code and all this. So we need to know like which one it was. So it's a band. I think whether it's abandoned or not, it doesn't matter. Maybe. Is an abandoned mutex object. Yes, I guess it was never unlocked, but then it. Yes, I guess we don't care. Let's just say if R. Okay, let's ask the AI to see if it can help us out. When would be returned when waiting for a process? Right, it might be when it crashes. Let's see. Or never. Any return when a thread waits on it. Right. Nice. That makes a lot of sense. So if R is greater than or equal to that and R is less than plus execute a running count, what we have is something which is terminated basically, and I guess we can just assert the rest or abort. We say call abort unexpected just do that. Ought to be good enough. Right, so we got yeah. E running handles. Now so we get the index, right? So index equal R take. Very nice. So what was the exit code? Gives us the exit code. And now if it's 0, successful. If it's not 0, problem. So yeah, and with this we also want to know, like, what was this? Was it a DAG command node which finished, or was it a find depths pass that finished? Something like that, right? So we want to know like what it was. So either it's if it's a command node which finished, you then want to sort of process that tree and then be like, these outputs are not, these outputs, their depender has finished, so maybe they can start running, right? Whereas if it's these passes, yes, I think we need another, so we have an executor, with an executor task. So the task is either, do you have a task kind? And the task kind is simply the task kind is either a command, like a DAG command, or it's a DAG find depths, okay? Now if okay, so the task will simply just be sitting here. Running tasks, yeah? So we'll fish out the, so if the dependencies one fails to run, that's a problem. Yeah, I think they're both issues, right? So you would basically report at the end, like, oh, we failed to build these guys, right? So I think what we want to do is kind of keep track of these errors and which ones were problems, right? So you do probably want to store the string as what command was running. So there'll be a command name, which would be a string. There'll be a command, the actual command which ran. Yes, you probably want to have like a nice name and then there's a long name. So I guess for debug purposes, you could display the long one, but typically you probably just want a short one. And yeah, you probably want to, I don't know. Yes, if we print them out at the end nicely, but it means we've got to collect everything. Or as they happened, we just print out the information. Then you have to scroll through everything, right? And then if it crashes, or if the build system crashes, you literally don't have the information now because you've lost, right? It never got printed out. So maybe the best thing to do is to print the bad things out as they happen. We can always change that. It's easier as well. So when you make a new task, you're going to say, right, there's a nice name that I want you to display, but also provide you the command as well. So we can do long names too. Right, so if the exit code is not equal to 0, so one error, problem. So equals 0 success, else problem. So the problem we can just print out. So all these macros here, what about these? Build error. And the error is going to be so what pass Henry did. So say exit code okay. And we need to gather the task. E running tasks index, okay? So it'd be task name. It'll just be a shorthand version. Cool. So if right, so if it's successful, I think the LSP died. Right, so if it's successful, we got to know like which task we have. So execute command and find dependencies. So the find dependencies one is easy. The find dependencies one is just going to be, we got ourselves the executor. We're going to just increment the completed count by 1. Right, and then I guess if all of them are done, we can like reset the DAG find depths array maybe. And then, yeah, anyway, we'll play around with it. So we just increment this guy. And, you know, this one is obviously a to-do. Then after, we now know, I think after all of this actually, we now need someone else's schedule. Right, so we know that that index was done. So now we try and search to see, is there anything else that we need to do? So we first, I guess, start with the find dependencies. So we go, right, if executor next to execute is less than, now we get the DAG as well. Hang on a minute. So we get the DAG here, we'll call it D. And we say, right, if the find dependencies count, right, it's less than that, well, I guess we get the next one. So we fish out, we then make a new into queue. So we can then say, that's not really a queue, is it? Yeah, so you can make a new task. Well, the task is here already. So you can then say task kind equal this guy. Task command is equal to the d find dependencies passes. So this is the index. So that's just a string. Lovely. Now I don't think we need the handles in here, which is great. So I guess we just have a bunch of strings. Might be the way to do it, which would be cool. Oh, we might need a name though. Yeah, we'll do a... Alright. You have a command name, so it's just like a shorthand version, but we'll offer a full command for verbose runs of the build system, I think. Or I have ways of doing both. Because most of the time you don't really care and it'll just be a bunch of spam. But then other times you might like, right, okay, there's a bug here, I wanna see some more stuff. So yeah, I think we'll fish out the name. Now this will be great when it's done. It'll be awesome. So the last one we don't really need in the executor. Oh, we should have moved this into the header file. I wonder why it's sort of complaining. I'm just keeping it here as a copy to visualize what I'm writing against. So the other one would be like, hey, have we got any type of command in the queue? So we've got a head and a tail, right? Is the head not equal to the tail? And if so, we have something to pop off. So we have this sort of DAG command queue. So I guess we can just call that command node. So that'll just be an index of the head ANDed with probably the capacity or something like that. Well, just mod it, I guess. We'll land it. One take cap. There we go. Then you obviously then increment the head. Classic queue behavior. Now you got yourself a node, so it's very similar to this. So we just do a DAG node, or DAG command. You do, your command node name, command node command, right? And then you do your task command node equal command node, yeah? Nice. Cool. So that's, but then what happens if you don't have any of those? Well, you just do a swap remove, whatever you call it. You grab the one from the end and replace the current index. So else if, oh yeah, so it's just an if, right? So if index plus 1, right, so you might have index 0, is if it's not equal to e running count, right? Because that would at least be 1 at this point if we've got here, yeah? So we're now saying we've got to get rid of this. Now we're saying is we're not the one at the back, right? So because we're not the one at the back, we want to take the one from the back. So we say e running handles, so other index equal e running count take 1, o index e running handles index. Okay, so you're just moving that. Then you're moving the task as well, yeah? Tasks is, what a name. Tasks. Okay, cool. So we then want to take the running count and then minus 1. Yeah. Cool. So this is the sort of executor. We can keep it single threaded, which is great because like all the multi-process stuff or multi-thread stuff has been handled because we're just launching multiple processes in the background outside of the application. The OS does all of the stuff, right? So this is great in terms of that. So here's this sort of loop, if you will, but I've not made it a loop, so we're just going to do that quickly now. So while 1, right, just keep running. But the only time you want to stop is when you just press Control C, right? Now, this, what about it? We need a way to put commands on. Do we? Yeah, so you might not have anything as well. So, yeah, so you'd actually be waiting for the file system in some other places. I went on some file system changes, and then when you're running, you'll be in this sort of loop here. And then when you're waiting, you'll be back in the whole sort of wait for the file system. So essentially, we need to get into here and run to do a DAG reset probably. Yeah, I wonder if you need to do an executor. Maybe this should just be for executing, right? So you just do executor. No, honestly though. No. I think this just needs to be a, yeah, so while a running count. That's what we do. So while there's stuff to run. Yeah, we'll make this just for executing like it is called for a reason. Nice. So executor run. It's in the name. Look at that, it's awesome. Right, so we want to also have a way to say executor Q yeah, so maybe you tell the executor by queuing stuff to run. Like, hey, queue up this command node. So I'm kind of thinking like, so you build the graph. That could probably be kicked off on another thread. Right, so you build the graph on the other thread. As you're building it, it's kicking stuff off. And the executor is like just waiting for stuff to be finished. Maybe. Right, stuff to think about. BRB. Welcome back, everyone. Yeah, so I was just thinking about this executor thing. Like, so as we try and build the DAG, right? We can't execute any of the nodes until the DAG is fully completed. But what we can do is when we don't build a node because we need to find some dependencies first before we build out that node and say it can go in there. We need to we can run those find dependencies because find dependencies have no dependencies on other dependencies, right? So when we find them, it would be wise to kick them off as soon as possible because you've basically got nothing else running at that point in time. Yeah, the best thing would be to kick them off as soon as you find them, but you don't want to kick too many off because you only have so many threads, and this is why we have the executor, because the executor keeps track of the number of threads of stuff running, right? So we could have an executor thread which just does all the stuff, right? Keeping track of what sub processes are running, and constantly waiting and ticking it basically. And its job is just to keep track of all that, I guess. And it only wakes up when it needs to sort of move on to the next task and all this, right? It's possible. Yeah, I think we might do that. So we will have multiple threads, but we just have this sort of executor thing, which just sort of ticks stuff away, right? So that would be kind of cool. And then the sort of main thread, if you will, is just going to go. It starts off by kicking off the executor. It just stays there. You can send it stuff by queuing it, but it will build the graph by the DAG. While it's building the DAG, it's like, oh, I've found these dependencies. You should really start with these guys. And then the executor is going to just be doing that. And then when the DAG is fully built, it can start executing the DAG. And then, by giving the root nodes to the executor, and then it can wait for the executor to be finished, I think. Yeah, so we can do some things like this. It's probably the best approach, so we'll do it that way. So really what you want is for this to be constantly running, and now it is just going to wait. Now, if there's nothing running, we probably want to wait on something else, basically. I don't know what that would be, but maybe, yeah, we'll just do the whole wait on address stuff. And we'll do like a wait on address executor. We'll just have like a signal there. I don't know what it would be, but yeah, just have a jobs count or something like that. Just puts the thread to sleep until it needs to be woke up. Now the compare address would be, I think wait on address can actually spontaneously wake up, I think. Let's see. Let's do a quick Google. And it gives me a whole essay. Yes. So it should be in a while loop. Dun-dun-dun-dun. So we're looking at like the value we're waiting for it to be. Right, so we're waiting for it to be while jobs count equals 0. So wait on the address. I think this is the wrong way around. I don't think this is going to work. Right, let's think about it for a minute. So typically you want them to be equal. Yeah, I think it's the wrong way around. So they're I think wait on address when they are the same is going to wait, isn't it? I think. Hmm. Yeah, so typically you have like a mutex, right? You would say you have like a boolean in there, and you'll say it's locked, so it's set to true. You're doing wait on address and waiting for it to be changed. Wait on address is a undesirable value. Let's go back to that for a sec. Yeah, so returns when the value differs from the compare at address. Yeah, so we have it as 0. Right, if it's equal to 0, we wait. Right, Mo wake up spontaneously, goes back and waits. But when it differs, yeah, that's what we want. Cool, so let's go to the executor. Something like that, yeah? So wait for the jobs count to be not 0. Then when a jobs count is not 0, it means it must be running something. So it can do a wait, something like that, yeah? Right, so you want to be able to queue some kind of like find depth pass. You know, I guess I guess at this point, yes, this never kicks off anything though. This should be kicking off the command. How does one do that again in Windows? Isn't it? It's create process, isn't it? Right, let's get all this stuff and tweak it about. So essentially, let's auto run. Command run, this is the one we want. It's got to be an old terminated string. I think it would be. So task. There. Okay. Then we get ourselves a new handle. So that'll go into tasks or running tasks. Whatever the index is, yeah. Cool. So essentially we want this to be kind of in here. So queue depths. So if there's room to run, I think you want that as there's a running count, there'll be like a running capacity, right? That's be a number of threads basically that we want to allow. So you would want a kind of a launch or run. So this code here basically, take that. Show you handles on it. So I guess you have your find depths index. Which one of these to run? We also want to know what task index. We can get the task. And we need the executor. So we launch a process. D. That's the depths thing in it. Cool. And then we put it into the running handles. Now, I'm thinking that this should just be an execute a run without taking a task. So if we just do this code here, the execute run, that launches the process. So from the task index, you could probably get okay, that's better. Cool. You know, maybe we can pass in a task index as well. I think we can do both. But yeah, I think this will be fine. Okay, so when we queue find dependencies, we're basically going, taking a look at, so we would have added the find dependencies to the DAG. And I guess the DAG will call this. We could have the index passed in. Yeah, you see, I wonder, right, if we should just queue the tasks up, and this way, yeah, I think we should be queuing tasks instead of, yeah, queuing tasks is probably better way of doing it. So, actually, we'll just call it a task queue. Right, I'll just, yeah, task queue. And that'll be the way. So, you have running tasks. Get rid of these. And then you might have a find. Nice. I think that'll be better. Let's just shuffle the code around a bit. So you queue a find depths thing, so you start pass in a pointer to it. You shall push on the queue. So I guess you'll have a way to get a task. And if the queue fills up, it crashes. So you get the executor and you say yeah, where have we done queues and stuff in the code base? Should have got one dot about. I think one of these. Oh yeah. We're not anding it, so we can just do a tail take. That's amazing. So, a minute. So, task queue tail take task queue head. So this is the count. If count is less than capacity, is full. All right. So we can then get the task by in the tail this time. So we do execute task, task equal e task queue, e task queue tail. And we advance the tail. Now the tail needs to be a wrapped, so we need to AND it with the one less of the capacity. Okay. So we can just return the task and there we go. We might have issues though with so oh no, we won't have issues taken from the task because I think we can. So you can have a push start and a push end, something like that, okay? This one will just signal that it's done. So this will essentially atomic fetch add to execute a jobs count. Just add one. And then we do a wake on address. Is there a wake address? Hey, Capuch, man, welcome. Is that a CPU thread schedule you run? Yeah, I guess so. Kinda. Like, we're making a build system. So we're trying to basically execute a range of jobs, one for as many threads that we have on the system. And this just has a queue of jobs or tasks which need to get done. And this is going to be on a thread in the build system. So the build system has a couple of it even needs to run a command that is next to run, basically. Say like, we have this tree of dependencies, and there's a few which need running, so those get queued up on the queue, and then they'll get dequeued by the executor thread when there's room for one, basically, and it pulls it from the queue. But there's also a find dependencies task as well, which could get ran as well, which is basically running clang-md, so it generates that deps file beforehand. So yeah, it's kind of like, it's like a job thread tasks scheduler type thing, yeah. You're some similar to C++, nice. Yeah, you typically write these things a lot, like basically it's like a command. Yeah, it's like a job system, right? You write these quite a lot in ways. This one just works with process handles rather than like function pointers. And yeah. So what sort of stuff you've been working on lately? What projects you got going? Wake by address single, so I guess we just wait on the address there again, yeah. Nice. So yeah. Then I guess yeah, the schedule is a bit different, but do do one of these guys. So we start a push, we fill it in with the bits that needs to be filled in. Task, find deps, yeah. Easy. Then we do an executor queue push end, yeah. Ta-da! So do one more different type of one. You can push on a command, yeah. Sort of game engine, recently finished my first render graph implementation. Cool. I also use CPU graph similar to this. That's why I caught my attention. Nice. Yeah, so you're like a job system and that. Yeah. Awesome. Yeah, graphs and stuff. Yeah. I've done render graphs in the past, but these days I just do a very simple one. I don't build it into actual nodes. I just do it in order. Do the sync code that way. Okay, so what changes then? So when it comes to looking for a new job, it is quite literally, have you got anything in the queue? That's what we should be saying. Have you got anything in the queue? So we'll read from is the head equal to the tail? So it'll be task queue head. So I think these need to be atomic because yeah, just because. Or access from multiple threads, right? Well, the other one is not going to load it at this point. Let's put it anyway. So atomic fetch add, just an inc. Right, so this is going to take from the queue. So you want to say e running tasks, the current index equal to e. Hang on a minute. What am I doing? Right, there's execute a run. Two different types of run. Damn it. Right, this one should probably be called execute a thread. It's a thread function. Yeah. So basically, I got this build system, and basic idea is you can run like, so how it used to work is you would just list the commands in order and it would build an array of commands, right? And it would, you could have barriers there, so you would wait for that previous command to finish before executing the rest of it, right? So you build a list of commands and it would execute it as a list in order. And then what would happen is it only executes stuff if the timestamps have changed on the files. Obviously, I had problems where I had to manually list out all the files, and there were some bugs as well in the implementation, and I want to make it such that it's like it was already launching across multiple threads and stuff, or sorry, processes, multiple processes. But yeah, it also needs to work where it needs to tell the game that, hey, these things have changed, so it can hotcode reload. So it has this watch pass, which is going to be rewritten, but it would basically just wait for the file system changes. And when you saved a new file, like a text file, or changed anything that was needed to be built, basically, it would then run all the commands in order again, and only change the ones which have timestamps that have changed. Now, the issue with this approach is that obviously you have barriers, so there's only one stream of where the commands can come in from and can be queued up. So what I've done is made a DAG. So it's literally just like this, right? You have files, commands which run, and dependencies. So this way you can actually have multiple streams of things which can run and have barriers on, right? So this VK shaders here is not going to run until the dependencies are found, for instance. This is not a graph we're going to be using in the end, but it's just an example, right? So this only runs when this is done. And when it's done, the barrier can be moved on. So we have barriers at each on each command now, basically. So it should be much better for utilizing all the threads that we want to do on the system. So we have this DAG thing that we're building, and how do you figure out the dependencies? So basically, when you discover a file, this is what we've kind of been trying to process through today. But when you come across a new file, say a GLSL file, it should have a dependencies file on the file system. Like on the average case, it will, from the last time you built it. But if you haven't built it yet, there's a -m command in Clang, which does a dry run. Right, it's not the best, but it does the job. And you should only do this on a clean build of the clean build. Now, I'm saying it's not the best in terms of like, it means you have to kind of parse the source file twice. Once before you can even try and build it properly. So it has to scan it again. But it only has to do that when the .d file, the Clang dependencies file doesn't exist. So you use the the -d and -f to get basically a list of dependencies for that single source file. So then what we can do is parse that up when we build the DAG and be like, right, here's the dependencies, and we can sort them all out ahead of time. So that's why in the executor, there's this sort of find dependencies. So when we try and build the DAG tree, we'd be like, does this dependency file exist? No. Go and make it. So it will have an incomplete DAG at that point, but we can still execute it mostly, just up to the points where, but it'll be missing ones which still need to find dependencies, right? Then after the find dependencies passes have ran, we can then rebuild the DAG again from scratch with those ones included in it again, right? And just keep repeating that process until there's nothing else that has changed. So yeah, that's how it works. So essentially we have this executor thread, which I'm just going to be running on the side, and there will be a watch system, which will, so first time it will run and build the DAG basically, or try to, it realizes it needs dependencies to be built. So it builds the partial DAG, so the graph of what to build. It has a list of dependencies to find, files for dependencies to find, or dependers to find. So it'll launch those on the executor and then wait for the executor to be done. And then it'll also launch the DAG as well, the partial DAG. And then it can, go around in a loop. And then after that, it just waits for all the files to change. And then when we notice the file has changed, we sort of take those events off, add them to the indexed file system, and repeat the process again, right? Build the DAG, see what's changed, execute DAG. That's the basic system we got here. So the resources are files that you check. So the resources are the files and you check file accesses. No. Yeah, yeah, so for every command that we run, say clang, right? Clang game.c, game.exe. That's going to include a bunch of files, yeah. So yeah, you check the file accesses, yeah. And those are your inputs, and then your output will be clang.exe. Right, so that means whenever any of your inputs change, you need to rebuild game.exe, right, basically. Executor task We're just going to take the task. I think so. Oh yeah, we want to try and launch it. So you got this like launch it thing, right? So execute a run. So we want to kick it off on the sort of run index and then the task. So E running tasks. I think that's what we want to do. So we get rid of that now, I think. So these are the key functions from the other. I don't know if we need the run function up here anymore. Maybe we do. The jobs which are queued up. Yeah, so I think you're going to, regardless, reduce the running count. Then we say if you got any jobs, great. E running count. Hmm. So while running count is less than E running capacity. Okay. So that'll be your sort of like running index, if you will. So I think you're basically just copying this then. No point putting it in a separate function if it's just used once. Right, I call it a run index. So you get the task. Head index. Yes, I guess you call it like a task index, if you will, queue index. So it'd be atomic load by checking in the task queue head. Now, if the queue index is equal to the atomic load of the tail, then what we have is a... Wait, we have an empty queue, isn't it? The 10,000 hour rule, is that what you're saying, 10,000 hours to be an expert, that sort of rule? Is that what it is? Yeah, I heard about it. You know, there's layers to it. I don't know, maybe it's a race condition, I'm not sure, because I think there's only one thread which is writing and one thread which is reading, so I don't think it is. But I'll think about it. Um, But yeah, so you'd at least get, so your stuff to execute, then you would run this once. Goes into atomics, but it does not happen at the same time. No, that's fine. Yeah, but it doesn't matter. So the head only gets changed by the executor thread. Right, the executor thread is the only one which changes it. So like, this one can only be atomic added. Or it is only going to be added atomically by this thread right here by one. Yeah. So it's not going to be, it doesn't matter if they change at different times because it's still safe. So yeah, it won't cause any problems basically. So Q index and yeah. But yeah, atomics are always fiddly. Like you can always bump into these problems quite easy. If you're not careful. Yeah, I'm thinking then we should probably get the task pointer here. Yeah, people typically just use mutexes and stuff and all that condition var stuff and blah blah blah. I know I just write my own sync primitives all the time, so yeah, I'm never a fan of like conditional var. I despise it with a passion. It's horrible. I just make my own sync primitives which make sense for the problem, typically. Yeah. Then I get people telling me you should never write your own sync primitives, and then I'm like, I like living on the edge, you know? So no, it's in the running. The run. Yeah, you should probably have already had that anyway. So run and task. Nice. Right. And then you launch the process and voila. Right, so is this a problem, the fact that we're breaking? Right, so we might come into this loop once, break, and then like you can end up waiting here on nothing. Is that a thing? Right? So you'd never exit here until you have a job. And when you have a job, it means that there's something on the queue ready for you to take. So you will at least run this once. That seems fine. Even a thing. Nice. All right. So wait for multiple objects. Right, success. After a success, we actually just remove it, right, by just putting the one at the end to replace it. then we just decrement the running count. Then we come back around again. Can we still be running? Is there still jobs to queue up? Yes. Queue them up by starting the process. Ta-da. Nice. Now, when it's complete, yeah, I don't know. Yeah, we'll worry about these problems later. Right now, this is good. Okay, making progress. So, should we start trying to plug this boy in, or what do we do? Should we start trying to execute the executor? Yeah. Right, let's move some of these guys into the header file. Here we go, okay? Now, in command VK shader, right, so you could be going through these. So you got a choice, right? So, does the dependency file exist? Get rid of that. If it does, which it should do typically, you build a DAG node or whatever. If it doesn't exist, you go, all right. Oh, I'm gonna go back to the, you go to the DAG and you say, I've got a new. Oh, this can work. I think. Maybe. We don't really care. So we did define dependencies. Yeah, you could probably just like, let's be honest. You could literally just bump allocate it with the you probably want a nice name. Yeah. Just bump allocate it. DAG find depths. Command name. And then we say to the executor, Q. I think that's what we want. So we might call it probably call it command find depths to make it a little bit better. So that would then be in command VK shader. Right, so we actually used to have another one around here, so let's put that there quick. We want to copy that back because it's the right command. So we need to dry run pass as the dependency file does not exist. So it's a special dash M. And we pass in the command. And now we pass in like a string. So I can call it VK shader depths for now. But we might do some other things. string format. Hey there, Sella. Welcome back, sir. It's been a while. How you been? VK shader find depths, and we're finding depths on some kind of input, right? So I guess we can do that. That might be kind of cool. That'd be like core. Anyway, what we're doing, it's the input. I think I just call it P in this function. Doing fine. Awesome. Lovely to hear. Yeah, we're currently just working on the build system right now. We're what am I doing? Yes, there's a few things that we're working on before we're ready to like start working on a game, basically. So the engine's getting into a place where it's like we should probably just build the game prototype first and then build the rest of the engine. When we have a game and know the stuff we actually need, rather than just building things that we might not use. So I'm currently just refactoring the build system right now, so it's awesome, and watches for all the file system changes and waits there in the background when you change a file, like an asset or a code file, that builds the things it needs to build, right? So you can then like use inter-process communication, basically write into a file that the game has memory mapped and just reads off a message queue, right? So we just pass messages to the build system, from the build system to the game, and it will be like, hey, reload the asset, and the game's like, sure. And yeah, so we're just building stuff like this so we can like get going with the game very soon. So I've got a lot of this stuff done. I think I've got the multi-threaded game engine or game loop. We've got the voxel model stuff mostly done. We're not doing voxel rendering for like the vinyl graphics. It's just there for placeholder art, because we can sort of change it and make it look like something rather than nothing, which is cool. But yeah, so we've got to do, I think, all these things where make sure the voxel models reload and make sure the build times are good, right? Build time's not good, it's sad, and iteration time goes. So we need to make sure they're good. But with this new build system, it'll be easy just to plug it in. But yeah, make sure Hulk reload works, and then yeah, I'll tell you guys what the game is soon. I'm kind of need to find time to work on a presentation so I can always see that is what we're working on. Right, so we just call it dep file. Right, this is, oh wait, we don't do that. Yeah. Nice. Okay. Nice. Right, I like that. That's good. So what should we do next? So we probably want to kick off that thread to have I got a thread something function? I haven't. Okay. So on Windows, let's find right, create thread. This guy. Should just be a one-liner. Okay. So we did build in it. So might as well get it to kick off the thread right away. We probably don't care about a lot of this stuff. Stack size, I don't know. Can I do like... We probably don't need to be that big. Say 64K ought to be enough, right? So that'll be thread... Sorry, executor thread main. The arg is not. And voila. Cool, so that gets kicked off. What's another thing to do? So I guess we can try and run it and see what happens. Alright, what could go wrong? So we need... Ah, crap. Meant to be simple, man. It's now no longer a simple thing because I have to link against the kernel or whatever. I think it's kernel 32, isn't it? No, synchronization. Done this in the past, and where is it? Yeah, L synchronization. So the build script, when we say build, we're gonna have more things. Right, task queue is full of zero items. Amazing. Right, so need to initialize that build in it. Here we go. So let's do another one. So g build dot when it comes to the executor, we want to have probably a running capacity of like a certain number of threads. So how do we, I think it's like that system info thing, isn't it? Win32 get number of, do we want logical threads or physical? I think logical threads. Let's do that. So logical including hyperthreading basically. Yeah, it says this. Comments. This info dot dw number of processes. There we go. Okay. Now we can say allocate me an array. Executor run in handles handle Here we go. Ah, lovely. Running tasks. Execute tasks. Cool. The other thing is the queue. So, I'm thinking the queue should probably have as many nodes as there are, something like that, and that should be enough. So allocate me an array where of execute a task size and probably the number of DAGs, DAG command nodes. I think that should be sufficient. And everything else will be zeroed. I think that will be fine. Cool, so let's keep going. Oh, the task capacity, we didn't say that, did we? There must be a power of 2. Right, allocate failed. No. Ah, great. Telling me it can fail sometimes? What's the code 47? Sorry, 487. What's that mean? Invalid address. Hey, Perry. Good to see you. Yeah, not doing bad. Quite tired actually. I was in Santorini last week. This is what it looks like. It's really nice, but they're like 2 hours ahead, so it's not massive. But my son kept waking up early, and you know, and also when we come back, he's waking up early still. So right now, quite exhausted and quite tired. Trying to remain sane while trying to program. You know the feeling. Yeah, it's lovely. It's amazing. Went on a boat. Swam to the shore from the boat and then swam back. It's quite fun. What else did I do? Yeah, went on some little hikes and stuff, sightseeing, and we nearly got ripped off in a few places, but that's holiday for you. But yeah, some places like there's just a few. There's this tourist trap, right? Oh yeah, this is the top of the island, so like you can see the whole island from like up here. Is kind of crazy, but where is it? Yeah, I think it's yeah, this place. This is in like Ia, or whatever it's called. There's the capital. Basically, like the whole cliff is filled with these houses, and when you go down to the bottom of these stairs, it's so long. It takes you like half an hour to climb down the stairs. And I had to carry my son down and up, and a pram at the same time. Um, but when you get down there, there's some restaurants, and you're so tired, you're like, okay, I'll get a drink. And obviously, everything's expensive, and all the food as well. Like I think you can get the cheapest plates were like 40 euros, and then there were some which were in the hundreds, right? Not hundreds. And yeah, it's kind of crazy. But yeah, good times. But yeah, how you been, Perry? Yeah, so for that restaurant, I basically skipped a meal. I let my family eat, and I ate the leftovers, as you do. Of course, I think that tried to run. I think it ran, but then like also, I don't think it did because Then we have a print. Oh, I got rid of it. So we should have some .d files now. We don't. Okay. This is where the debugger out now, I guess. So we would like to kind of see that maybe, and we'd like to see this. Interesting. Does the wait on address actually load? I don't think it does. No, it does. Of course it does. I think so. You've been busy at work, also tired, not so much time for project, really sad. Sorry for my project, sadly, but the editor can load up and save levels, nice. And implemented some collision detection resolution. Cool. Amazing. Yeah, it's always the reality, isn't it? It's not as much time as you hoped, or things take longer than you hoped. You have to account for that. There's the multiply by 2 thing and multiply by 4. Right. If you're unsure, multiply by 4. If you're sure, multiply by 2. Needs refactoring as always. Yep. Went a bit sideways with the custom immediate mode UI. Oh yeah. Amazing. Why is this giving me code? I didn't ask for code. Anyway. Right, so wait on address and it waits. Yeah, then we get here. Yeah, so the problem is so basically red debugger doesn't pick up on atomics for some reason. Maybe it's fixed that problem, I've just not updated it. But I solved that problem in my main code base by not using atomic and do my own custom functions. Maybe I might just do that again. Anyway, but for now, we can just print, right? So like, observed value. I'm not quite up to date on red debugger, but do know Linux support is coming soon. Yeah. Yeah, I think it's got it mostly working. Well, by mostly I mean it boots up and I think it can even debug stuff now. But I don't know how well they've not been looking. Right, so it's saying 1 here, but it's not really loaded it. So I guess you have to load it. Like what did I do in my other primitives and stuff? Oh, well, you always load it afterwards, right? That's great sample code. Cool. Go. Oh, nice. GDSL error. Both M and MD are specified. I must use one at some time. Cool. Lovely. Wait, and then it wait at a -1. Right, I think we should fix that problem whilst we got it as reproducible, I think. So, is this reproducible? Yeah, but also what? So I'm trying to write a pointer as a string, I think. Sorry, not a pointer. Anyway. Ignore my words. Alright. So like so wait for objects. Yeah, I think we run this one more time. Oh. We can interesting. Why is it working now? Not really running anything though. Right, here we go. Boom. So we go here. Go to launch. Right, something crashes. I think. What are you talking about? Yeah, but why is it exiting? I would like to know why. So I think what's going on is it's crashing, but it should break where it crashes, right? So oh, is this the other executable? I don't know. Let's oh, I should have switched that off. Crap. Oh. Can rack debugger handle process? Create process? Pretty sure it can. Pretty sure it can. Why would this end up calling exit? Though? I'm confused. Right, let's print out 1 and then 2. Right, so obviously it's not related to red debugger, but like, so what about task? Command data, right? What is that? Seems pretty sensible. Obviously, we was getting errors before, but not getting errors anymore. Right, so that's a bit weird. And all we did was fix a problem here with these strings. So here it manages to run it though. Weird. Man, what could the issue be? Failed to execute. Not even running it. Not even getting to that point. Maybe there's memory corruption. Maybe. Yeah, so we're using that new sort of DAG alloc. Like, yeah, that's fine. It's the same as the other one. Yeah, it's completely fine. So I wonder if there's something else which runs, like one of these aborts or something. I know what DAG is, but why are you trying to, what am I trying to achieve? So basically we're making this build system, and so it's gonna be a build system which just keeps on running. And whenever I change so it's cross editor, right? We don't care what editor's being ran. You literally just run the build system. The build system will execute in parallel all these jobs which you have for it. So you might say, compile these C files, link these files, or move this asset into the game directory, right? And all these little tasks. And it's the job of this system to essentially find well, that's what the DAG is for, right? Is to find all the dependencies and make sure they run in the right order. But it's also the job of this system to tell the game what has changed so it can hot code reload it, basically. But yeah, that's what we're trying to achieve, is a build system is independent from the editor and will scale when I add new assets whilst we're prototyping, right? The whole point of reason why we're coming here and doing the rewrite now is because it kind of needed one, and when I'm prototyping, this is going to get in the way of that. So I'm just dealing with all those problems right now, basically. That's the plan. Right, I don't feel like you're seeing the new line. I think that's the problem. Could be wrong. Yeah, it's it's not too difficult, I would say, but yeah, it's just yeah, just a bit fiddly. And yeah, it's going quite well. I've already built the easier version of it. I'm just doing the this graph stuff. Yeah, I would typically avoid trees if I didn't have to do it, because trees do get a bit confusing sometimes. That's why I've done the graph viz dots thing. So I've got this graph being output basically. And right now it's not doing anything, but yeah, so I put this file and it just visualizes the tree as a graph. So I don't have to write any code to do that. Man. I'm confused on why when it does a create process, it like causes my process to exit. Oh, wait, it's doing a fork, can it? No, it won't be doing. No, it's not doing that. I am confused. Right, see if AI could help. Why would create process call exit? Well, it seems like it's called an exit for some reason on mine. I think it's a memory corruption problem because it's inconsistent how it was working before when I just changed something completely seemingly disconnected. There's already zeroed, right? Yeah. Absolutely bizarre. It could be another thread, right? Which is like doing. So what I'm going to do is create process. I think it could be another thread which is causing, which crashes, which causes some of that. So if I just put a while one here, hopefully the compiler doesn't be smart and optimize that out. I think it does, doesn't it? Let's see. All right, here we go. Oh. So it appears like maybe it's not running that at all then. Yeah, I don't think that while loop is going to be in there. Let's print out something like, what can I do which does something? Let's do a volatile. Volatile. Let's just read that structure. And then like, that should keep it around, right? There we go. Infinite loop that I wanted. Now we keep running. So it should never exit. Yeah, never reaches there. Oh man, this is super weird. So like, Yeah, there's something fishy going on. It's just being exited somehow. Usually the debugger though catches it, right? So maybe we can manually step, I reckon. Oh, right. I see what's happening. So it's actually just returning from the function. Man, that's so dumb. Right. So we can literally just... So it doesn't even get a chance to get there and then it will exit. So I guess we can just do a while loop at the other end. So this is where we need like a watch, basically, right? That's the next thing to do. Cool, so rather than MD, here on the dry run, just an M. No such file or directory. Yeah, but why are you trying to output that? Hang on a minute. Command VK shader. You shouldn't be trying to output that. BB fault. Right, seems to be doing stuff. So I think these are the dependency files, right? But they're not being output to the file system for some reason, which is kind of dumb. So like MF is not being respected, right? So basically what you want to do is just pipe. Right, have a good one, Peri Peri. Good to see you. Hope you have a good weekend. I'll see you very soon. God bless you, sir. Right. Okay. So we're at a good place now. We've got the executor done today. We've much more on the DAG side of things, realizing we're going to rebuild the DAG every single time the files have changed, we need to build something again. We basically regenerate the DAG again from scratch and see what we need to do. What else have we done? Yeah, we'll put the executor on another thread and we've made a DAG allocator basically for the lifetime of the DAG. Improved the dump a little bit and yeah, changed how the file nodes get made. So next stream, which will be on Sunday, 7:30 p.m. GMT +1, we're gonna get the kind of watching code working, if you will. So we're gonna keep trying to, build the DAG, do the find dependencies stuff for this DK shader, and then we'll write, when we've got that working, we'll write the watch code. So it'll basically watch for the files and then add them to the index and then run it again type stuff. That will go in here. But yeah. So yeah, we'll just do that next time. Lovely. But yeah, in the meantime, guys, there's a Discord if you want to come and chat. And thank you for everyone who's supporting the channel. Appreciate you all. If you want to support the channel, you can go over to the Ko-Fi page and get this engine to run on your own local machine and have a play as well as a thank you. But yeah, schedule's all down below in the Twitch page. And yeah, I'll see you all Sunday. Catch you later. Have a good weekend. Bye bye.